Okay, the following is a preparation for an Ohm's Law practical that we're going to do at some point during lesson times. The whole objective of this video is so you get a greater understanding of current, voltage and resistance. Okay, so if you just watch the short video, then hopefully you'll understand those three concepts. Okay, right. The whole idea of the practical find out about something called Ohm's law is finding out what the link is between voltage and current. Now, in order for us to think about the link between voltage and current, we first have to think about what the two things, voltage and current, actually mean. Okay, now we should all be familiar with circuits already from our work at Key Stage 2 and early on in Key Stage 3. Okay, but we'll just go through a bit of a recap. So, what we need to remember is, in circuits, usually there is a power supply. Well, I say usually, there will be a power supply. Usually there is a component. Most of the time before you'll have seen a bulb, I've drawn a symbol for a resistor. And usually the circuit is complete. Okay, so here we've got our cell, okay, and we've got our resistor here. Now, from chemistry, we know, okay, that metals, these contain delocalized electrons. Now, from chemistry, although it's all physics really, okay, we know that electrons carry charge. Now, those electrons carry charge, and that is what your electricity essentially is, okay? Now, what makes those electrons move in the circuit? This power supply. So the power supply supplies voltage to the electrons that are in the circuit. Current is the movement of these electrons around the circuit. So, for example, if this is 6 volts, okay, and we have got our electrons in the wire, remembering that the wire already has the electrons in place. We've got the electrons flowing through our resistor. Okay. Then what happens is, some people choose to think about this as the battery providing a kick to the electrons and forcing them around the circuit. What happens is, the voltage supplies the electrons with energy, and that's free to move around the circuit. Okay? Now, what would happen if that voltage was to increase? Okay? Now, what would happen would be the current would increase. That means that the amount of electrons flowing past a certain point per second would be higher. Okay? So, let's say this is 9 volts, then what starts to happen instead? Your electrons move faster, etc. Okay? Now, the problem with this is heating. Now, if we think back to what's in a metal, and we think about the positive ions that are in place, what's going to happen to those positive ions when it gets hot? Okay? Now, think about that. You're going to have a higher amount of thermal energy, and because you've got a higher amount of thermal energy, these are going to gain kinetic energy, and these are going to vibrate more. Now, if your electrons trying to get through, you've got a bigger obstacle because these are moving more. So, you have less current getting through per second because there are more collisions with these positive ions in the metal. Because you've got more collisions with the positive ions in the metal, we say that the resistance has gone up. Now, if current decreases, so if we have decreased current, that means that the resistance has gone up. Now, because the resistance has gone up, okay, then we have more collisions and less current can get through. Okay, so we think of resistance as the difficulty that the electrons experience to trying to get through the circuit. Okay, now Ohm's law, what Ohm's law tells us is that as voltage increases, the current, and we use the symbol I for current, okay, increases too. Now the reason why we use I is because all the other letters, we've got capital C for capacitance, we've got lowercase c for speed of light. Intensity of current was what Ampere used, so he used I. Okay, now we say that voltage is directly proportional to current, and because the voltage is directly proportional to current, we get a graph like that. Now that's only true if the voltage stays the same. If the voltage changes, okay, I said voltage there, that's an error, I mean temperature. If the temperature stays the same, this is true. If the temperature increases, you have more collisions and your resistance goes down. We can see this when we have a look at the behaviour for a filament lamp. Okay, if we have the behaviour for a filament lamp, then the current eventually decreases because of these collisions. Okay, hopefully that should set you up for your Ohm's law practical that we'll have a look at next lesson. We're going to investigate how changing the current changes the voltage through a resistance, and we're going to talk about what Ohm's law actually is. You may want to spend some time on the internet having a little look at what Ohm's law is and what the associated equation is. Sorry about the slip with temperature. Thanks for watching. All the best.